Today's going to be 34-2, and we're going to take a look at trig graphs and period change. And so once again, we're going to identify the different parent graphs for sine, cosine, and tangent, solidify that, and we're going to understand the period change of trig graphs. So if you remember, these are those parent graphs. I said this portion to this portion for cosine, this portion to this portion for sine, and then this portion all the way to this portion right here for tangent. Those were our parent graphs. Now these are just the graphs as they naturally look without anything being done to it. There's no period change, there's no shifting, there's no stretching, there's nothing going on. And we said that the important values here are going to be like 0, pi halves, pi, 3 pi halves, and 2 pi. And then the important values for tangent were 0, pi halves, and pi, and we said that to help us memorize it, Dad will help us dot asymptote dot to be able to graph those tangent values. And then we talked about this idea of vertical stretching and shrinking, which we defined as the amplitude. And we said if we have a value in front of our sine and cosine functions, we call that the amplitude. And so if I had f of theta equals 3 cosine theta, what it does is it actually stretches the graph vertically. And so this amplitude, is going to apply that vertical stretch or shrinking to the graph. Now we're going to talk about the horizontal stretching and shrinking. And so we're actually able to stretch this trig function horizontally by multiplying your variable by a given constant. And so we're going to say that this constant is going to be b. Now when you're stretching and shrinking it along the horizontal, what you're doing is you're affecting its period. Now I know I talked about it yesterday, and now I'm going to define it today, but a period is the number of radians or degrees it takes for a function to complete one full cycle or revolution. And so since parent functions, sine and cosine, have a natural period of 2 pi, and even looking at that, here's that parent function for cosine, it traveled the distance, so if this is where it started, it went all the way to 2 pi before it started changing, or before it started repeating itself. And so that was the old period. And so just know that sine and cosine have that original period of 2 pi. So let's graph f of theta equals cosine of 2 theta. Now examining what my cosine graph looks like, originally, my original period is 2 pi. Now to find the new period, you're going to use the equation. Basically, it's the old period divided by b. Now, if you take the old period and if you divide it by b, that's going to give you the new period. So in this case, my b is 2. So if I did 2 pi over 2, my new period is going to be pi. Now, look what happens to the graph with that new period. It's almost as if I took the graph and I shrank it horizontally, like I pushed it in. And so, believe it or not, now it travels a shorter distance, right? Instead of traveling all the way to 2 pi before it started repeating itself, it only traveled from 0 and then all the way to pi before it started repeating itself. And so you actually get twice as much function in that same space. Let's take a look at one for sine. Now, same idea here, this 1/2 theta, or this theta over 2, this is the same thing. If you see it, you need to assume that your b is going to be 1/2. So if this was the old period for sine, if I did 2 pi over b, so that's 2 pi over 1/2. Now I know some of you guys are like, wait a minute, what? Right, those multiply together, that's how you get the 4 pi. Notice that it got stretched along the horizontal. It's like it got pulled along the horizontal, and that's why it now took a distance from 0 to 4 pi before it started repeating itself. And so now what we're going to do is we're going to sketch the following one full rotation. So 5 sine of 3 theta. Now the reason why we're going to spend some time actually graphing it is because originally I said the important values were, we said 0 and pi halves and pi and 3 pi halves and 2 pi. Well, notice these values changed. It's 0, pi, 2 pi, 3 pi, 4 pi. How do I find those values? And so that's what we're going to kind of go into a little bit more. Now the first phase of doing this, what we're going to be doing is we just need to describe the graph. What's the information that we know about this graph? So for example, my amplitude, that's going to be a positive 5. I also know that because it's a sine graph, my sine graph, the parent function, looks something like this. And so I know that that's the kind of the pattern that I'm going to use when I go through and graph this. And then the new thing we just learned, the period, the original period over what b is. And so my period is going to be 2 pi thirds. And so now if this is an image of what my graph looks like, what do I label my graph? Now to do that, what we're going to do is we're going to take, I'm going to call this like the inside of my function, that 3 theta. We're going to take that 3 theta and we're going to put that between 0 and its natural period. Now the natural period before we did anything, that was 2 pi. So I'm going to put that between 0 and 2 pi. Now I want to solve for theta. And so I'm going to get the equation 0 is less than or equal to theta, which is less than or equal to 2 pi thirds. Now, remember that box where I put all those important values in there? Now we can go and discover what those values are in that box. Now the nice thing about it is that value goes here. That value goes here. So I have the ends of the graph. Now I have to find the middle part of the graph. Now to find the middle part, we're going to use a little bit of geometry to help us, and the midpoint, which we also talked about earlier this year. But with that midpoint theorem, if I add the ends and divide by 2, I can find that middle value. So if I do, so to find this value here, 0 plus 2 pi thirds, divide all that by 2, I'm going to get 2 pi 6, or if I reduce that, I'm going to get pi thirds. And then for this value here, 0 plus pi thirds, divide that by 2, I'm going to get pi 6. And then this value is in the middle between these two, and so once again add those together and divide by 2. Pi thirds plus 2 pi thirds, divide that by 2. I get 3 pi thirds, so that's going to be 3 pi 6, and that can get reduced into pi halves. Now the reason why I wrote it in both the 6 and then also the reduced form is because the concept of scaling. It's going to be really, really important that we scale our graph correctly, and it's going to be much easier for us to be able to label it. So I could also say that this 2 pi thirds, if I multiply top and bottom by 2 over 2, that's going to give me 4 pi over 6. Now the reason why I did that is because if you notice, every value is going up by a 6. 1 6, 2 6, 3 6, 4 6. That means that this next value here, I immediately know it's 5 6. And if I go in the negative direction, that'll be negative pi 6, negative 2 pi 6, negative 3 pi 6, etc. So that's why scaling is really important there. The second reason why scaling is really important is because it allows us to know how we're going to label our graph. So eventually we're going to come across an example that could look like this. And let's say those are our first two values. Well, what's going to happen is we're going to sit there and we're going to be like, oh, well, there we go. And what you're now insinuating is this distance here of pi fourths is the same as this distance here of pi halves. Well, they're not the same. And so if I scaled this, if I said, well, actually that's really 2 pi fourths, then when I go to draw it, I can recognize, oh, look it, there's 2 spaces when I draw that. And so it allows me to scale this much better. Okay. So now that I have these values, like I said, I know how to label this. This is going to be 0. We said this next one is pi 6. We said this next one is going to be pi thirds or 2 pi 6. And we said this next one is going to be 3 pi 6 or pi halves, and then this last one is going to be 2 pi thirds. And so we can go through and we label that. And now that I know how everything is going to be spaced here, what I can do is I can start plotting what the values from my parent graph. So this first value starts here on the center line. So I'm going to draw it here on the center line. The second value goes up to the amplitude, so I'll draw it up the amplitude. We said the amplitude is 5. The next value crosses the center line again. So at the next value across the center line, the next value goes below to the amplitude, and then the last value crosses the center line again. And then I could go through and I can trace my graph. So the first thing that I did here was I basically just described the graph. So all these 3 steps here were just describing the graph. I determined which parent graph to use, I found the amplitude, and I stated the period. And so I even verified my period is from 0 to 2 pi thirds. Then I have to find what these values are here. And so to do that, I took the inside of my graph, which was 3 theta, and I put that between 0 and 2 pi. And I solved for theta. So I divided everything by 3, and so I got thetas between 0 and 2 pi thirds. For that box, that value box that had all those important values, we know they're going to change, and so this represents the first value in the value box, and that represents the last value in the value box. And so to find this middle value right here, we use the midpoint theorem, add these two together, divide by 2, I get that value. To get this value, this is in between these two, so I add this together and divide by 2, and I got that value. To get this one, I add these together and divided by 2, and I got that value. And so now I took these values and I was able to take them and I was able to plot them on the graph there. I used these values here to sketch it. Here it goes up, crosses, goes below, goes back. And so I was able to graph my graph. So look at the next one. So we said that these first 3 steps, it's all about describing the graph. And so the things that I know is like my amplitude. I know that my amplitude is going to be 4. My parent graph is cosine. And so cosine normally looked like this. But because the fact that there's a negative in front of there, right? We don't have a negative amplitude, but that negative means a reflection. So it's going to go down here, it's going to go up, and it's going to go back there. And so my graph will look something like that. And then my period, I'm going to get 2 pi, my original period, divided by b, which is 1/3, and so that'll simplify into 6 pi. And so now I need to take that inside portion, which is theta over 3, and put that between 0 and my original period, which is 2 pi. Solving for theta, I multiply everything by 3, so I'm going to get 0 is less than or equal to theta, which is less than or equal to 6 pi. I can create my value box now. The first value goes here, the last value goes here, and so add the ends, divide by 2, you get 3 pi. Add these two together, divide by 2, you're going to get 3 pi halves, and add these two together and divide by 2, you're going to get 9 pi halves. Now for scaling purposes, this is also going to be 6 pi halves, and this one will be 12 pi halves. So now I can go through and I can take these values, right? I'm going to graph it now. I can take these values and I can label them onto the graph. And so now I need to transpose the image of my parent graph. So the first value's down here at the amplitude, so -4, and then the next value crosses, and then the next value goes up to the amplitude at +4, crosses and goes back low. Whoops, goes back below. Now notice the image here, they're like almost identical. And so then I can trace my graph through. So now we're going to move on to tangent. Now with tangent here, the original period, if you remember, is just pi. And that's something that we defined in our lesson. So if my original period for tangent is pi, that means it's going to have a new period of pi over b. So here's my parent graph for tangent. Nothing's being done to it. But now if I do pi over b or pi over 2, if you notice, it's still as if I took the graphs and I kind of like smushed it in more there. And that's why I was able to fit much more tangents within that same space there. So just remember, the natural period for tangent is pi. So instead of 2 pi over b, it's going to be pi over b. So now sketching with tangent, once again, we have to describe the different things. So for amplitude on tangent, right, there's none. The only thing that has amplitude is sine and cosine. Now, graphing an image of tangent, we said that dad normally helps us. It's dot, asymptote, dot. Now, normally the graph does this. But because of that negative there, it's going to go down this way and it's going to go up that way. And then my period, we said it's now pi over b. And so my period is only going to be pi thirds. Now, once again, I have to find those values that go on the graph. And so I say I have to take whatever the inside is of my function, so 3 theta, and I'm going to put that between 0 and my original period. Well, my original period is pi because it's tangent. So then I divide everything by 3, and so I'm going to get 0 is less than or equal to theta, which is less than or equal to pi thirds. And so now I can create that value box. Now the nice thing about tangent is there's only 3 spaces for that value box. First one goes here, last one goes here, and so if I add the ends and divide by 2, I'm going to get pi 6. Now scaling this, I can say that this is the same as 2 pi 6. So now I can label this. There's pi 6, this would be 2 pi 6, this is negative pi 6, and this is going to be negative 2 pi 6, and this is going to be 0. And so we said dad helps us graph this. So dot, asymptote, dot. And so at 0, I can draw the dot. At pi 6, I have my asymptote, dot, asymptote, dot. You just continue on in that pattern. And so looking at this, I know that it's going to have this type of sketch here, and it's going to kind of come up here. But it's asking us for 1 full rotation, and so as long as I'm graphing in 1 full rotation, it doesn't necessarily matter what range I am in. And so in this case, I can graph it here, or if I would wanted to, I could cut it off here and then just have it here and just have these 2 right here. So I could have this one and this one be it, or I could just use this part right here, and so I could have, you know, this graph go here and this piece go here. It doesn't necessarily matter. I just had this one shown, and all I need is 1 full rotation here. So this concludes our lesson, and if you guys have any other questions, please leave them in the comments.